Welcome back to week 7, and in this last video we're going to talk about forecast construction and some of the types of forecasts that can be created, and then accuracy and precision. So once you have collected all this data, most of it is automated as far as the collection goes, as we learned in the last video. And all this information from weather buoys, from surface stations, satellite data, from radar, usually all of this information is what actually goes into creating forecasts. And nowadays these forecasts are created by using computer models. And one specifically is called the Advanced Weather Interactive Processing System. If you are curious about what a meteorologist does at maybe NOAA, at the National Weather Service, or your local TV station, what you can do, if you head to the week 7 information, if you haven't already checked out these videos, you see the National Weather Service office tour in Tampa Bay, Florida. This video kind of walks you through the different computer stations. You get a look at what life would be like as a meteorologist and what they do on a daily basis, which is pretty neat. And then check out this short video that shows how the actual landfall and location of where Hurricane Sandy went based on prediction, and then showing you the actual. It's pretty neat. Weathermen are not always wrong, as many people often think. So, and then definitely check out all these other videos about the history of numerical weather forecasting. Pretty interesting to look at what we had 200 years ago, what was used, and also what was used 50 years ago, and then some of the other neat links to check out. So these models are based on the probability that certain kinds of weather might appear in the future. This probability is determined by comparing the current conditions, the current weather conditions, to what's happened in the past. So taking these weather conditions and running it through this computer program to say, okay, have we had this similar set of conditions in this area before? If so, what happened in the future? So they can use that information to plug into that model. So going off of what's happened in the past to predict the future. And then also using these numerical model of these physical processes to simulate the behavior of the weather system. So taking into consideration maybe one of the conditions is a little bit different than what happened in the past. How is that going to affect it? And then they can run their models using these different scenarios, and also putting different data in to come up with a couple different ideas as to what might happen. So some of the forecasts that can be completed and used are persistence forecasts. So this is based on the persistence of current weather. So maybe that can have a lot to do with climate. So places like Death Valley, California, pretty dry. It's dry, very low cloud cover, very little precipitation for most of the year. Some places are pretty easy to predict, and some places are going to be humid most of the time based on where they're located. So we can use the persistence of certain weather conditions. So maybe it's been hot and dry for a long time, and the weather coming in, it looks like it's going to be hot and dry, so it's probably going to stay that way. So it's that persistence idea. You can also use climatological forecasts that can be produced. This is based on climate stats or statistics from the past. So here we can see information for Albany, New York. 2013 data is the blue line. This is data that is actively being collected. This is the temperature that was actually measured. These other colors indicate the normal conditions in the light green in the center here. So this is going to be what the average data is going to come up with. The blue indicates the record minimum for this location, and then the red shows the record max. So the idea is throughout this time frame, throughout this year, they're predicting, and they can use this information to say, okay, well, we're probably not going to get anything outside of this range. We're probably going to be sticking to this center green area and maybe going a little bit above or below. So using this past climate data to predict what might happen in the future can also be used. And then here you can see precipitation and snow as well. So you can also use analog. So this is based on weather signs. So certain things indicate something might be on the way. So cold fronts, there's certain triggers and signs to show that a cold front is coming or a warm front is coming. Your textbook has some great charts that describe exactly what some of those signs are. So if you're curious, you should check that out. And then we can use numerical models. This is based on mathematic modeling of physical processes. So this is actually what's used the most. So we take these newer, more accurate, more powerful computer programs that we are using can take a lot of this information, can take the climate data, can take the persistence data and put it into these mathematical models. So here's a picture of some of the servers that are used and computing stations that are used to actually work some of these computer models. Lots of power. Here you can see a picture from a long time ago of a very old computer that was used. So if you haven't checked out the history of weather forecasting link, you should definitely do that. It's pretty interesting information on there, walking you through how things were done in the past and how they're done now. So numerical models are basically running a computer program by plugging in certain values and setting up certain conditions that you want to try to simulate. Some rules of thumb for running these computer models. One thing is to run them multiple times over and over again to see if there's any limitations that may exist in your model. Different models may be more accurate for different conditions. So some computer models may be really good for determining temperature change, maybe for precipitation, but not accurate for determining what the cloud cover might be, or so on and so forth. So models are produced and made to be able to predict certain things. So oftentimes one model is not going to be good for everything. Oftentimes these models are tweaked with analog and climatological methods. So they may run a model and then decide, okay, I think we need to factor in some climate data to this because this isn't quite looking right. And then if you run these models over a shorter time span, you're probably going to have more accurate forecast as a result, instead of running it for maybe 10 days or a month. And you guys are going to take a look at your forecast charts and take a look and see what you think about the 10-day forecast. So some of the different forecast ranges that can be determined are nowcast, so what's happening now. Severe weather alerts. Your book has some good section going over those different weather alerts. You can also look at short range forecasts, 12 to 72 hours, medium range, 3 to 10 days, long range would be seasonal and annual, and then climate projections would be centuries. So if you visit the National Weather Service website here, you can see some of the different forecast maps that they have actually produced for a specific time frame, which is pretty neat. You can see national forecast chart, national temperature, short range forecast, precipitation, temperature, predominant weather, chance of precipitation, sky cover, wind speed and direction, precipitation amount, surface analysis. So all sorts of really, really neat information that you can check out. And this link is also in the weekly video information. So all these different forecasts can be found on any major website, which is pretty cool. And so here we have the forecast for Hood River. You can see the nowcast is present. What are the current conditions? And then you can see they have this looks like 1, 2, 3, 4, 5-day forecast going from the day out 5 days, and then below that there's a 7-day forecast as well. And if you scroll down, you notice that the information gets less and less detailed the further out you go. That's because it's harder and harder to predict that information because it is so far away and conditions can change pretty quickly. So when these different forecasts are put together, we have these two ideas of precision and accuracy. Precision is the amount of detail. So how big of a scale are you looking at the entire country versus just Oregon or just Portland, Oregon? So precision is how much detail are you getting? Are you getting all sorts of information? Are you going to get temperature, humidity, cloud cover, precipitation, dew point, all that information, or are you just going to get temperature out of that forecast? So precision is how much detail you're going to get, whereas accuracy is going to be the measure of how correct that prediction is. So the factors that influence the accuracy of forecasts is going to be how precise the forecast is. The more detailed it is, usually the more accurate it's going to be. The stability of the weather patterns within an area. Oftentimes this is why the forecast might be incorrect, because the weather patterns aren't very stable and they're changing rapidly, and that's can be a hard thing to model if you don't know that things are going to change that rapidly. Also, the amount of data available. So on the west coast of the US, we don't have a lot of surface data to go off of. So that's why there's a lot of weather buoys and ship data that's being collected. What we have off to the west of us is the ocean. So we're relying a lot on satellite information and not a lot of surface data available. And then the duration. So the shorter your forecast, the more accurate it's going to be, because forecasting over a few days tends to be easier and more accurate than trying to predict a week or more in advance. In this graph here you can see shows you how over time how the accuracy of forecasts of both 36-hour and 72-hour forecasts has increased over time. So we go from like the 80s to the 2005. So our accuracy has improved dramatically throughout history because we've been able to use higher powered machines to run these forecasts. So we've gotten better computers that have more computing power to be able to run these more detailed models to more accurately predict what might happen in the weather in the future. So that's a wrap up of weather forecasting, how these forecasts are created, how the different types that are created, precision versus accuracy, and weather forecasting as a whole. Definitely check out all those links that I have posted. They are very helpful, and I will see you in lab.